that is 8 feet wide, carrying a load that reaches 7 feet above the ground. Clear a semi-elliptical arch on the one-way road that passes under a bridge. Assume the arch is 10 feet tall and 30 feet wide at its tallest and widest points. So understanding that we're looking at a semi-elliptical arch means that we can start to visualize what exactly this question is asking us. Because written out in words, it can seem a little confusing. So we're going to envision a semi-elliptical arch. Now, for the sake of the drawing, I'm going to exaggerate that semi-elliptical arch just a little bit, just so we can see it in the space. So here's our semi-elliptical arch. Now, we're going to imagine, for the sake of this conversation, that we are positioning that semi-elliptical arch so that the middle of the bottom or the center of the semi-elliptical arch is going to be at 0, 0. Understanding that the semi-elliptical arch is 30 feet wide at its widest point, that means that our semi-elliptical arch is going to end over here at 15 and over here at negative 15. And seeing that the arch is 10 feet tall at its tallest point, we know our top is going to be at the point 0, 10. Now, what we're looking for is, can a truck that is 8 feet wide, so if the truck is 8 feet wide, can it fit through here? Obviously, if it drives real close to the end, it's not going to fit through. We're assuming that the truck is going right down the middle. So we should have a pretty balanced truck traveling right down the middle of the semi-elliptical arch. We know that the truck is 7 at its highest point, and we know that it extends outward 4 on each side. A width of 8 means we're going out 4 on each side. So what we're looking for is, now obviously the way I drew this, it looks like it will, but what we're looking for is, will those two corners clear the semi-elliptical arch as the truck drives right down the middle of the arch? The key to answering this question is to both understand where the truck is positioned in relation to the semi-elliptical arch and what would the equation of the semi-elliptical arch be. We can actually start with that one. That's a little bit easier. If we imagined an entire ellipse, we would have a horizontal axis with radius 15, and we would have a vertical axis of radius 10, giving us the equation x squared over 225 plus y squared over 100 is equal to 1. We know our ellipse is going to have that equation. Now, obviously, we're only concerned with the top half of the ellipse. That's not relevant to our question, though. That's not going to end up making a difference in our calculations. The second part that I mentioned before was understanding that this point is at x is equal to 4. So however far out we have to go for, we're going to see if that point on the ellipse, 4 comma something, won't be hit by this point of the truck, 4 comma 7. We want to make sure that this y value is greater than that 7. Therefore, the truck would clear the arch. The way to do that is to figure out what that y coordinate is. We substitute x being 4 into our equation for the ellipse. We know that that's 16. We know that this is 16. 4 squared is 16. We multiply by a common denominator to clear out the fractions. The common denominator for 225 and 100 is 900, leaving us with 16 times 4, the extra 4 that comes from 900 divided by 225, plus 9y squared is equal to 900. We get 64 plus 9y squared is equal to 900. We subtract 9y squared is equal to 836. We divide by 9. 836 divided by 9, which is 92 and 8/9. And then we finish with a square root of 92 and 8/9, giving us a final height on the ellipse of 9.64. So an x-coordinate of 4 corresponds to a y-coordinate of about 9.64, meaning 4 feet to the right on the semi-elliptical arch is 9 feet off the ground. The truck is only 7 feet off the ground, so we can be assured that yes, the truck will fit inside that space. All of this came from our ability to write the equation for the ellipse. We wrote an equation for the ellipse, we substituted in the number that we knew, and we went through our process of figuring out what its corresponding y-coordinate was. From there, we saw that the truck would easily fit underneath that height. Therefore, the truck would be able to pass through the tunnel.